Okay, right? So light independent is the most important reaction, but you can't just do the light independent reaction because this is an anabolic reaction needing lots and lots of input and of energy, right? So to build up one carbon dioxide into 6 carbon glucose, we need lots and lots of energy. So what's going to give this energy is the light dependent reaction. So this is the energy we are getting towards the light independent reaction. So top of the arrow, write down ATP, NADPH needs to come from the light dependent reaction. So we can't just do the light independent reaction because it's going to rely on the energy produced during the light dependent reaction. Write down the inputs and outputs. Write down underneath. Huh? There's 3 inputs, 3 outputs again. Okay, so inputs and outputs. So inputs are start from the inputs and then write down the opposite for the outputs, right? Don't do it all over the place. If you write carbon dioxide, this is the one that gives the carbon for glucose. The opposite side must have glucose. Don't write glucose somewhere else. If you write ATP as an input, the opposite needs to have ADP and PI. If you write NADPH, when it just unload the high energy proton, it needs to be NADP plus H plus. Is this clear? So there's going to be a lot more than light independent reaction. Huh? We have to know like the cycle. So write down light independent reaction, also called as the Calvin cycle. So that means it is a cycle, right? It's not the Krebs cycle. Calvin cycle is different. Krebs cycle in cellular respiration, right? So I just wrote it down like one reaction, but it's going to happen in a cycle. There's going to be lots and lots of things involved. I will do the Calvin cycle next week. There's going to be RUBP involved. You have to know everything about the RUBP enzyme. But write down this question and answer the question. There's no questions here, right? So the first question is, Okay, so the first question is, can the plants produce glucose without sunlight? 2 marks, huh? Is there an electron transport chain in the photosynthesis? Identify a location where the ATP production, energy production takes place other than inside the mitochondria. Mitochondria is the organelle for ATP production, right? You know from last year. So is there any other place where you can see energy production other than in mitochondria? Answer the question, 5 minutes. Right, so the first one is asking whether the plants can produce glucose in dark. So you might see some books use the dark reaction for the light independent. Where is it? Light independent, sometimes called as dark reaction because it doesn't use light. But don't write dark reaction. I want you to remember light independent and Calvin cycle, the same thing, right? Two terms. Finish. Okay, can the plants produce glucose without sunlight? The answer is no. Light independent reaction produce the glucose, but light independent reaction to produce the glucose using the carbon dioxide need the inputs. Light independent reaction to produce the glucose out of carbon dioxide need the energy from the light dependent reaction. Right, so without energy taken from the light dependent reaction, the light independent reaction can't take place. That means the glucose production won't take place. So the answer is no. Is this clear? No, because products of light dependent reaction, the energy needs to be an input for the light independent reaction to produce the glucose. Right? You can't produce glucose without sunlight. Second one, yes or no? What is the answer for this one? Is there an electron transport chain in photosynthesis? Yes, there has to be, right? Remember the thing I said? All the other things, whatever the other coenzymes at one point needs to undergo electron transport system. So it includes NADPH. So inside the chloroplast, there is an electron transport system chain, right? Within the two membranes, it takes place. Right? So is there an electron transport chain in photosynthesis? Yes, there has to be, because we produce NADPH, a coenzyme. The energy needs to be converted to ATP through the electron transport chain. Mitochondria, we are learning it, but only thing is we are not mentioning it, but it needs to be within the two membranes. Otherwise, you can't take the NADPH energy into the ATP. Mitochondria is the main organelle that produce the ATP, but you can find ATP production elsewhere inside the chloroplast. We just produce the ATP, highlight the ATP. So this is the ATP production. Other than inside the mitochondria, you can see the light-dependent reaction producing energy. These are exam questions. Huh? We just produce the chloroplast, produce the energy during light-dependent reaction. I'm going to give some questions. Just one-page questions. I'm going to send the previous question as well. It's a Word document, do it. Huh? I don't know what happened my PDF. I sent photosynthesis 2 questions. It includes the one we did earlier. Just do the first one only. Yeah, the one I haven't done the things that going to change the rate of reaction. Yeah, you can do only the first one. Question number 18, do 18. Just do this one. Huh? I will go through the limiting factors later, but before that we have to do the Calvin cycle in detail, light independent reaction. So do the first one if you want to all of them, but I'm going to go through the first one. So can you see the arrowhead? So arrowhead is towards the product. Yeah, always look at the arrowhead. So NADP goes in and the product needs to be. Oops. right? Arrowhead always towards the product. You can read the arrows, right? Everyone knows how to read the arrow. So light dependent reaction occurs in thylakoid membrane in the chloroplast. NADP goes in input and the output is NADPH. And ATP is the output, so input needs to be ADP and PI, right? ADP PI goes in, output is the ATP. The main reaction is 6H2O breaking down into 6 O2s. So they have given the product NADP. So what needs to come in is the NADPH. NADPH goes in, come out as NADP. Read the arrow properly. You need this for Calvin cycle, Krebs cycle, everything. ATP goes in, output is ADP and PI. 6CO2 becomes C6H12O6. Occurs in, what is it, the stroma. Right, so this is what we did. The most important thing is to read the arrows properly. NADP goes in, output is the NADPH. Right, so you can do the other questions, the limiting factors. We did that in last year, right? The temperature and everything, those good questions. So Calvin cycle next week, right? I'm done. Bye.